If you walk into any hospital, you will see that it's absolutely crammed full of high-tech equipment. For example, an intensive care unit, you can see the patients are on ventilators, there's sophisticated monitors looking after the patients. Without this high-tech equipment, clinicians would have a really difficult job. In fact, many of the leading advances that have been made in medicine in recent years are down to engineers, and in fact not down to clinicians. Here at Bradford we have a long tradition of working in medical engineering, and we have an international reputation in our research. With particular expertise in areas of clinical biomechanics, human movement, biomaterials, and also infection control. The MSc that we've designed here at Bradford is a logical extension of all the work. It really is research focused. We've designed it so that you can actually sort of pick and mix the modules that you want to do, so you can actually tailor it to your area of expertise. And we want to give the students the opportunity to achieve excellence in their chosen field. We cannot stress this enough. It's a research-driven MSc.
Okay, so this is the Biomaterials and Polymer Characterization Laboratory. What we've got in here is a range of equipment, both microscopy, physical characterization and chemical characterization, as well as a biological laboratory as well. So what we have here is an atomic force microscope. The business end down here has got a very sharp tip on a thin cantilever, and what we do is to scan that across the surface of a sample. As it moves along, the tip follows the surface much like a record stylus, and we shine a laser onto the back of the cantilever, which is reflected back onto a photodetector here, and we can use that to monitor the position of the cantilever as it bends to follow that surface.
So this lab is actually called the Vision and Mobility Lab. It's probably one of two labs in this country, a research lab in this country, that use biomechanical modelling techniques to understand how vision is used in locomotion. You'll see on the computer screen here we've got someone doing some step downs. And on the computer screen we've recreated our performer using biomechanical modelling techniques. So you attach markers to the individual. You can see on the computer screen we can then join these markers up to create a stick figure, and it's the stick figure that you take measurements of. You'll see our subject wearing goggles. These goggles allow us to manipulate vision, so we can switch off the goggles remotely. So during the descent the goggles will be switched off, and then we try and understand or determine what the impact is of vision being switched off.
You've probably heard about hospital superbugs and the problems that they cause, bugs like MRSA and Clostridium difficile. Well, here at Bradford we've got a world-class research group looking at this problem. We call ourselves the Bradford Infection Group, and it's a multidisciplinary team which has very close links with the hospitals in Bradford, Leeds and Harrogate. We're very fortunate to have a world-class facility, this pathogen control chamber, which is one of very few in the world. It enables us to actually mimic, to actually mock up hospital wards, and to actually look at the ways in which microbes, dangerous microorganisms, spread around the hospital environment. And then we can look at experiments and interventions to break the chain of infection. We can also spray in dangerous pathogens, superbugs, into this chamber in a safe manner to look at ways in which we can actually kill them off. And we've worked in this field for many years now, and we've got very close links with the National Health Service in the UK. And it's quite exciting, and we're hoping to make a difference.
The big difference for me between medical engineering and traditional engineering is the impact that it has on people's lives. So before, when I was working on valves in gas lines in the North Sea, that's not a topic which many people are interested in. As soon as you start talking about joint replacements, everyone knows somebody who's had a joint replacement or is thinking about having a joint replacement. And it makes a real difference to individuals' lives, whether that's saving life or improving quality of life. One of the things which is unusual about Bradford is that because we've been doing medical engineering for a long time, we've got a very integrated multidisciplinary team. So we do actually have engineers who are also microbiologists, who are also experts on biomaterials, biomechanics, and can bring that clinical background or that scientific background into their engineering work.